Welcome, everybody. It is October 23rd, 2024, and this is the Smart Energy Decisions webinar series. I'm Deborah Channel, Editorial and Research Director of Smart Energy Decisions. Our webinar series has been developed to deliver insights and useful information for large electric power users. Today's presentation, brought to us by Trane, is Scope 1 Emissions Reduction, Why All Eyes Are on Heat Pump Technology. So why now? I mean, heat pumps have been around for almost 100 years, but it looks like they're being rediscovered, and it's by organizations that are looking for low carbon solutions for heating and cooling requirements, and especially those with sustainability goals that include Scope 1 emissions. So in today's presentation, we have Trevor Jolson of Trane, and he'll dig in on this technology to explore how it dovetails with corporate sustainability commitments and to give us a future outlook on the technology capabilities. And he'll also include insights from real-world examples of emission reduction projects that have leveraged this heat pump technology. But before we get started, we have our usual housekeeping tips. Make sure to enable pop-ups within your browser. Turn on your system sound to hear the streaming presentation. If you need any technical assistance, you can press your F5 key or Control R to refresh the browser. And if that doesn't work, click the help link or submit a question, and we'll respond right away. You'll also see on the console for today, you can download today's slides, and there are a series of links to information on heat pumps and decarbonization strategies that Trane has provided for us, and I think you'll find them interesting. If you want to submit a question for our speakers, you can do so at any time during the presentation. Just type it into the Enter a Question box, and we'll leave time for Q&A towards the end of the session. The team will follow up if they don't get to your question during the live broadcast. So just check out the navigation bar with all the widgets at the bottom of your screen. So let's talk about smart energy decisions for a moment and everything that we offer our community. We are very mission-driven at our company, and that mission is to enable positive global change by providing the information, inspiration, and connections that you need to make smart energy decisions. And as you know, we really focus on the end user. It's the commercial, industrial, institutional, and government energy customer, and their connection to the supplier community. This ongoing webinar series is one of many programs and services that we produce, all in fulfillment of that mission. We have our Smart Energy Voices podcast series, exclusive research, our daily news and newsletters that I know you're all signed up for, and of course, our events. We are already looking forward to our 2025 slate of events, and that includes 2 net zero forums and a renewable energy forum. And these events are a great mix of energy customers and solution providers. And we have our patented one-to-one meetings, educational sessions, and lots of networking opportunities. And these are really great locations for 2025. We're looking forward to them. So go to smartenergydecisions.com/events for more information. And now let's get started with today's presentation from Trane. Again, it's Scope 1 emissions reduction while all eyes are on heat pump technology. Our presenter today is Trevor Jolson, and he's Enterprise Energy Services Account Executive at Trane. And I'm really excited to have Trevor with us today. He conducted a general session at SED's Net Zero Forum Spring earlier this year, and he was terrific. No pressure, Trevor, but let's bring you in and get started.
We'll take a little bit of pressure. It's about heat pumps, and pressure is a big part of that. So we'll accept the pressure. But you're such a professional, tough act to follow. So appreciate the high bar that you set, Deborah, and glad to be here. I wanted to kick off with just a little bit of the background and genesis on why Trane chose to give this presentation and this webinar to this audience. My Gen Z colleagues use a phrase, having a moment. And the reality is right now, heat pumps are having a moment. We are seeing massive amounts of requests come in from our clients, and it's a kind of bizarre request for us. It's, I want to do a heat pump project. And no one comes to us and says, oh, I want to do an HVAC project somewhere. It's just kind of a base requirement that you have, or I want to do building automation somewhere. It's this very specific request for, I want to do a pilot on a heat pump project, and I want to evaluate this technology for my organization. And so we've been seeing this request, and then we're also seeing when we look at search engines and search engine optimization, we're seeing this massive boost in inquiries around heat pumps. So people are really curious about them, and we thought that this session would be good to break down specifically for those end use customers, the basics of heat pumps, but then also how it applies to a net zero journey and some of the hurdles and opportunities that you're going to see while you look to build heat pumps into that net zero journey. So quick personal intro and I guess a free ad for Smart Energy Decisions. You're seeing my smiling face there. One of my favorite parts about the forums is that you get a free professional headshot. This is not an AI photo. This is an actual headshot from Smart Energy Decisions. I believe this was the one that was in Fort Lauderdale area. So if you make it out to a forum, you can get a beautiful smiling headshot as beautiful as that one. I'm calling in from Dallas, Texas today, and I'm going to be brave for a second and share just one thing before I'm going to drop my background. So I'm actually a heat pump user, and I'm calling in from a shed that's in our backyard here in Dallas, Texas. And Dallas is obviously a climate that sees a number of extremes, but I'm someone that uses a heat pump at a personal level to keep this 15 by 15 shed that is my office space, mostly focused on keeping it cool because it's Texas. But obviously, we've found headlines for some major winter storms recently, and it helps keep me warm as well in those situations. So quick framing for today, and then I want to go ahead and ask the group that's here with us a poll question. Deborah mentioned this is a 100+ year technology, and it's now just getting back to its moment. So we're going to review what this technology actually is, what makes it work, what makes it different from traditional HVAC systems, and some of the pros and cons that come from that. And the plan of attack is we're going to review heat pumps at a very kind of high macro level, whether they be for a residential, commercial, or industrial application. But then we're going to zoom in because this is about end use customers, specifically on the business end of heat pumps. Why are we seeing more requests from corporations? How does it tie into your sustainability commitments? And why is it such a key tool in your net zero journey? We'll close out by looking at some of the increasing incentive. Incentive right now is a double-edged sword. There's both carrots and sticks of opportunities, but then there's risk and regulation. And then we'll talk a little bit about the future technology outlook for heat pumps. But I'm going to give it back to Deborah. We're going to do kind of a foundation building poll, and then we'll get into the content.
Okay, thanks, Trevor. And here's our poll question, our first one. Just to get us started, how knowledgeable are you about heat pump technology? So please choose one of these answers. I've never heard of heat pumps. I've heard of heat pumps, but don't really understand them. I think I understand how heat pumps work, and I have a lot of experience with heat pumps. So choose your answer. We'll give you a few seconds to get in there. And I have to admit, on our pre-call, Trevor asked me to answer this question. And I was honest, I would be a B. I've heard of them, don't really understand them. So I'm looking forward to hearing more during today's presentation.
And Deborah, I anticipate a lot of Bs. You said that you might ask me what I think will come through.
Yes.
What I do want to say is we've specifically structured this presentation to be valuable, whether you're an A, B, C, or D response in this, but it's helpful to kind of see where the collective lies and where the marketplace is at right now.
Right. Yep. We will have something for everyone today. Okay. We're going to let a few more. The answers are still trickling in. We have a lot of people out there and they're all answering. So I'm going to give you seconds.
And we did get a lot of people that registered for this, didn't we, Deborah?
Yeah, there is a lot of interest in this topic.
Yeah,
I was surprised. I think you were not.
We have that this is what we should be talking about. And that
right, exactly. It's a good measure. All right, let's see what our audience says. Okay, about half, 52% say, I think I understand how heat pumps work, but awesome. Almost a third are in my camp. I've heard of them, but don't really understand them. Good, only 1% say they've never heard of heat pumps. We welcome you. You'll learn a lot. And 16% say they have a lot of experience, and I think they're going to be they're going to learn a lot from today's presentation as well. There'll be a lot of takeaways for them.
Absolutely.
Okay. All right, so Trevor, back to you.
Yeah, so I wanted to bring Gene Simmons into the presentation as early as I could. That was one of my objectives, but one of my favorite acronyms is KISS, Keep It Simple, Stupid. And before I lose the audience, I want to just hit directly what makes a heat pump different than traditional heating technologies. And that is the fact that heat pumps do not generate heat or cooling. What they're doing is they're actually moving it around. So because they're not generating this heat, and we're going to talk about the movement process, but because they're not generating, they're just moving from one source to another, they're able to run much more efficiently because they don't go through that generation process. So traditional heating, we typically think of boilers and burners, and those are something that are likely going to be fueled by natural gas. You'll still see some oil boilers out there, and we absolutely see electric resistance boilers as well. But generally, natural gas is what we're going to see. And when you're using natural gas as a fuel source to generate heat, you are indeed generating heat. So because of that, there's some inefficiency that takes place in the generation process to be able to use the BTUs of the natural gas to actually make the useful heat for either your process or your space condition. Now, comparing that to a heat pump, we mentioned a heat pump doesn't generate. What they're doing is they're actually moving heat around. They're taking heat from air, water, ground, or waste heat, and they're moving it into some type of use that a building or a facility has. And we have some more graphics that are going to really break that down. But ultimately, that heating mode runs at ultra high efficiencies because of the fact that it's about movement of heat as opposed to generation of it. And heat pumps in their name use heat. So people generally think of them as a tool or a technology for heating. But part of what makes them so valuable is this reversal mechanism, which is the cooling mode. When I'm in my shed here and it's 105, I was going to say 95, but that would probably be unrealistic for Texas. When it's 105 degrees, what the heat pump's doing is it's actually pulling all of the hot air out of this 15 by 15 building, and it's expelling it to the outside ambient. So it's cooling the mode the same way it would heating, just in reverse. Now, this is the visual that I kind of teased a little bit earlier, that when we were prepping for this, I said that, I like that, that's a good one. That makes everything make sense. So we're going to give credit where credit is due. This comes from the International Energy Agency. For anyone that's not familiar with the IEA, they are a fantastic NGO. They actually, on an annual basis, release a World Energy Outlook that, for my money, is the greatest kind of macro view of the energy dynamics that we have across our globe. And it just came out, I think, 2 weeks ago, maybe. So if you're looking to do some side research while we go through this, World Energy Outlook from the IEA is a great resource. But this visual really helps to demonstrate how you are using a heat pump to take heat from a source. And that source can be air, it can be water, it can be ground, or it can be waste heat. And then you're taking it through this refrigerant-driven, compression-based process to be able to create a useful heat that is ultimately going to go into a sink. So again, what we're doing is we're moving heat, moving BTUs from a source to a sink. We're taking it from one area and putting it into another area of utility. In the way that we're doing that, and where this is really gonna hit the road for everyone, is this one area that says electricity and has 3 lines. We're using electricity at the compressor to be able to make that a useful heat and take it to the temperatures that are required from that source to that sink. All right, this is a chart that I think kills some of the sacred cows that are out there and breaks through some misconceptions as it relates to heating efficiencies. I'm going to start at the blue line that says electric resistance right there. So something we run into with our clients is They know that electric resistance has a 100% efficiency, or a COP of 1, which means the amount of energy that you put in is the amount of energy that you're getting out for heating. And that's absolutely accurate. And in our minds, which we're all pretty smart, our thought is, well, if it's 100% efficient, it can't get more efficient than that. But what it's actually calculating when we're looking at efficiencies and when we're looking at COPs, which stands for coefficient of performance, is how much energy are we putting in, how many BTUs are we putting in, and how many valuable BTUs are we getting out that can be utilized. So in a heat pump, where we're able to take a source and we're able to up-level that to useful BTUs in a very highly efficient process, we run at these ultra-high COPs. So you start talking about running 200, 300, 400% efficient relative to an electric resistance alternative, which is basically just a giant toaster that you're using to create heat. Now, we talked about natural gas, and that is generally the standard for space conditioning for a building right now. And natural gas burners, they're going to run between 80% to 100%. There's certainly a derate factor. If you have an older unit, it could fall below 80 or be closer to 80. But you can see here how the efficiencies and the energy efficiencies between the technologies differ. Now, one thing with the electric resistance and the natural gas burners is they're really stable, right? It's a flat line, but potentially a good flat line, not the kind that you would have at a hospital. That would be an issue. But in the heat pump technology, we are subject to the ambient in the outdoor conditions that we are dealing with. So you'll see air source technology as we move into the winter, we start to see COPs decrease on average. Water source decreases as well, but not to the same degree. So you're looking at performance over the course of an entire year. So you can see COPs dip, but you're looking at the overall average for the performance of the asset. All right, more research that was done ahead of this. I just told you about how great heat pumps are and asked the question, well, is this a unicorn technology? Is everything perfect about it? And in my research, I identified that unicorns actually do exist. You're looking at a Siberian unicorn. It was identified in Kazakhstan about 25,000 years ago. They found a skull, and it's like a 6'5" frame on this brown beast that you're looking at. And I absolutely love the headline to the point that I had to put in this presentation, which is the good news is unicorns are real, but the bad news is they're hideous. So unicorns do exist, but they might not be as glamorous as we think. As it relates to heat pumps, I want to just be upfront about some of the realities of limitations that we have. And we're going to talk through these. We're going to talk through them as hurdles, but then we're going to talk about some of the market conditions and some of the technology advancements that are addressing the hurdles. The first one is hopefully an obvious one, and is for anyone that's looked at a heat pump project. Electricity is expensive, especially if you are based in the United States, which I believe most of the audience is here. Relative to natural gas for an equivalent amount of energy, electricity is typically 3 to 5 times as much. So when you start talking about those efficiencies, you have to be able to make up for the cost differential between electricity and natural gas with the efficiency of the system to be able to break even on the operational cost. The other limitation is performance in extremes. There are certainly extreme climates where you start to see the COPs dip. There are extreme climates where the heat pump is going to have to lock out because the compression cycle can't run any further. And I'm going to hit on that on the next slide, but it's certainly a consideration when you're doing design and evaluation for your building is what your climate looks like. One thing to throw out there for those that are on the line that follow science and climate change, certainly if we're warming, we're dealing with a situation where we're going to be dealing with less winter-based extremes. So that is something to consider with heat pumps, just kind of the macro movement that we're all on right now. And the last one that I want to hit on, which can sometimes be forgotten, but is certainly critical in this, is that heat pumps require more refrigerant within your buildings. When you have a boiler, you do not have refrigerants running through that system. If you move to a heat pump for your heating source, you now need to think about refrigerants and the global warming potential and the cost of those and the regulations around refrigerant the same way you do your traditional HVAC system. So it's a new consideration on the heating side that historically hasn't been there. And it's certainly one that we as industry are starting to address. All right, I got one more point I want to make on the technological side here, and it's some active myth busting. So we talked about cold climate performance and performance in extremes. The Department of Energy is doing a fantastic job on this myth busting, and they hosted what was called the Cold Climate Heat Pump Challenge, where they brought in a number of the manufacturers of heat pumps, including Trane Technologies, and they gave us this really difficult scenario where at 5 degrees ambient, we had to perform at a 2.1 to 2.4 COP. We had to be able to perform in these ultra low temps. We had to have low GWP refrigerants. Trane chose to put our heat pump into a residential application in Boise, Idaho. Not sure if anyone's, or if you've been there before, but it gets cold in Boise. It has some extremes in Boise for the winter. And we were able to announce in June that we passed the heat pump challenge. I know other manufacturers have as well. But within that, we were able to highlight a 15 to 20% energy reduction for that residential site relative to a traditional heating source. So we're able to prove the performance in cold climate, and we're also able to prove that there's energy efficiency that comes with it as well. All right, so I wanted to use this as a break in the conversation and hopefully bring some people back in if I lost anyone at this point. But everything that we just talked through could apply to your home, could apply to your business, it could apply to your manufacturing plant. What I want to do is make it about business and talk about the realities that we're dealing with as end users, and generally end users in the smart energy decisions community that are committed to a net zero journey and to driving sustainability outcomes. For those that have been in the smart energy decisions community for a while, and Trane has been one, this is something that we've shared that really kind of anchors us with our clients, which is our belief, and that's a belief based on conversations with dozens and hundreds of institutions and end users, is we are in a moment in time right now, if you look at the today that's on there, where we're transitioning from an ambition era as it relates to sustainability to an action era. The very first CDP scorecard happened in 2000. And then we have science-based targets telling us that we need to get to net zero by 2050. So that gives us a 50-year period. The reality is we are 2 months and 8 days away from 2025, which puts us smack dab in the middle of that. So we as end users of energy that have commitments and have alignment to science and science-based targets, we're reaching the action era where we need to start driving results. Maybe we've gone out there and we've said that we're going to be net zero by 2040 or carbon neutral by 2035, whatever those goals might be. But truly, if we're not already in the action era, everyone needs to move in that direction right now. And we're going to break that down just a little bit further right here. So in all the conversations with clients that allowed us to understand that ambition and action era, we saw two main levers that differentiated where a client or an end user was at as it related to their action era. The first is the need for funding, which is probably a pretty obvious one. We have some clients that are finding themselves in what we call the capital fist fight. And they're in a massive growth period right now. They're building new plants, and the money's going to go to expansion of the business. We have other clients that have been able to set aside money for sustainability initiatives, and they use that capital pool to drive what they're looking at. Depending on where you're at in your access to capital within your organization drives where you are able to go within your action journey. The other element is this need for speed. We were able to diagnose, I keep using medical terms, I'm not a medical professional at all, but we were able to diagnose, I'm going to stick with it so I sound maybe a little bit smart. The Net Zero 2040 becomes a line of demarcation for corporate customers. The reason why is because if you are committed to Net Zero 2040, and I'm going to do what they told me not to do, I'm going to advance and then go backwards. But if you're committed to Net Zero 2040, that means that the next piece of equipment that you buy, which most of our assets have a 15 to 25-year useful life, the next piece of equipment that you buy is one that's likely going to be with you when you set your goal in 2040. So in terms of the need for speed, and I'm cycling back here, I apologize everyone, but in terms of the need for speed, if you said that your organization is going to get to net zero by 2040 or sooner, you have a clear call for action to start addressing electrification because you need to eliminate fossil fuels. And as you start to renew the assets within your portfolio, you need to be thinking about the fact that those assets are going to be with you when you get to your goals. For those that are working under an interim goal or a net zero 2050 goal, you may have some more time to do piloting and explore and look at best alternatives. But you also may find yourself in a situation where your executives say, you know what, net zero 2050 isn't good enough. We want to go ahead and pull it forward to 2040. And then all of a sudden, if we're in charge of actually achieving that goal, we find ourselves smack dab focused on electrification. And electrification really does become the high pole in the tent for achieving net zero. When we look at scope 2 in the electricity side, all of these levers that are referenced have value, but the electricity, while we're finding more difficulty finding RECs and renewable resources, there's very clear line of sight to being able to get to VPPAs or large-scale REC purchases, which allow us to essentially neutralize or get to net zero alignment for our scope 2 electricity. When we look at fuels, there's no equivalent VPPA that's out there, and anything that would be viewed as renewable natural gas doesn't have the maturity of the electricity side to be able to effectively offset our fuel usage. So electrification finds itself smack dab in the middle there of a net zero journey because of that fact that if we're going to be able to achieve a goal by 2040 or 2050, if we continue to put fossil fuel assets into our facility, if we continue to make heat with an asset that uses fossil fuels, we're either going to need to retire that asset before our commitment date, we're going to need to find an alternative that's not currently there because there aren't mechanisms to be able to effectively offset this from a financial perspective, or we need to change our commitments altogether. So electrification really sets the need for speed, and to use that phrase again, it becomes the high pole in the tent for net zero journeys. Now, as we look at electrification, and I'm going to spend a few minutes on this slide because it's absolutely critical. There are some considerations when going into an electrification project that if you have a portfolio of locations, you need to be able to evaluate that portfolio for these variables to determine where electrification is going to be beneficial today and where you're going to have opportunities in the future. So the first is emissions factors, and we mentioned that we're going to share a case study and we're going to get to see an example of this, but the general thinking is, okay, if I move from fossil fuels to electric heat, I'm going to reduce my emissions. That's a partial truth. What you're going to do is you're going to reduce your scope 1 emissions, but you're transitioning from a scope 1 to a scope 2 emission. And depending on the emissions factor of the grid that you're on, you could actually see a near-term increase of the emissions related to your heating by moving to an electrical source. Now, the customers that we talk to, their perspective on that is a couple things. One, the grids continue to decarbonize, more renewable energy continues to come onto the grids. The federal government has said that we will get to a 100% clean grid by 2050. So I'm not sure who wants to believe the federal government, but I think we have to use that as table stakes as we start to set strategy. The other thing is that Scope 1 and Scope 2 emissions aren't created equal from a corporate or institutional standpoint. And the reason why is because we have a clear mechanism in RECs and VPPAs to address our Scope 2 emissions. We don't have that on the Scope 1 side. So even if you're increasing your Scope 2 emissions, you know you can still get to your goals. If you have Scope 1 on the books, you don't have clear line of sight to that. Now I'm going to move to the next one, which is a fancy term, which is spark spread. What spark spread means is the difference between the cost of two sources of fuel. In this case, we're talking about natural gas and electricity. There's a reality where this year natural gas prices have really plummeted. We had some significant volatility with the commodity the last couple years. Certainly in Europe and overseas, we continue to see natural gas prices high. But here in the United States right now, natural gas is cheap. And we've all been part of the conversations where electricity pricing is going up, AI, data centers are driving demand, and we're continuing to see electricity go up. So we have to be able to evaluate the difference between the cost of a kilowatt hour of electricity and the cost of an equivalent unit of natural gas. Now, across the country or across the globe, there are going to be markets where that is more favorable. There are markets where the spark spread looks attractive because of the dynamics of the market and what they are looking to incentivize or the structure of the rates. On the flip side, there's going to be other markets where natural gas is dirt cheap and electricity is really expensive. And if you're making your decisions based on the OpEx impact, it's going to be really hard to make electric heat work. So spark spread is really important. And this is something where across the globe, we've seen that spark spread start to tighten. It'll be interesting to see here domestically. Do we see either market forces or artificial forces like carbon prices start to close that spark spread? Now, the last consideration I want to call out is electrical infrastructure. Many times in the projects that we do, we see that moving to electric heat can establish a new peak demand for the facility. So ensuring that you have the electrical infrastructure in your facility, and then ensuring that you have the electrical infrastructure to bring more power into your facility and that the utility has the capacity to serve you is really important. We're going to talk a little bit about like the value of a heat pump as a cooling and heating mechanism downstream. But one of the value points I want to hit on right now is that if you're making the decision on your cooling, you've already sized for the electrical that's required for the cooling as it relates to the heat pump's capability to provide heat. Then you need to be able to have some type of backup source to cover for it. But electrical infrastructure absolutely has to be a consideration. We've seen the need for electrical upgrades kill a number of heat pump projects. All right. I want to go ahead and just break through some of the electrification technologies and go back to that original concept we had of a source in a sink. So these are all heat pumps, but they are all different heat pumps that are using the source, in this case of air, and they're going to a different sink to be able to produce heat. So we have air-to-air heat pumps, which are looking like your traditional rooftop unit, air-to-refrigerant, which is a VRF-based system, and then we have air-to-water system, which is mostly a hydronic system that's going to run air-cooled chillers. These are all technologies available today. They're packaged systems. For those that are closer to this is for the people that were in the I know heat pumps well, or I feel pretty close to them. In terms of the temperatures that we're able to get to with this, 120 degrees easy, 140 with some slight modifications. And in terms of where we have line of sight, in terms of the temperature range we can get to with a package system, 180 is something that we feel is realistic within this decade. I talked with our product management team to make sure I got the real-time insights for those temps that we thought we could get to. But generally, if you're looking to get 140 or below, there is package technology today that can get you to those temperatures on the water side. Now, when you start to get into more complex systems and you start to use water as a source, you can get to higher temperatures, and you can also get to some more value streams to be able to support the project. So this is, you use water as the source. It can be kind of confusing because it's water source, but then you call it ground source, but the ground source system is using watering as the tempering, or you're looking to actually recover heat off of a hydronic loop that you have running within your existing building. So on the ground source side, ground source geothermal systems are becoming more and more attractive because they're tied to the Inflation Reduction Act. And they've actually been something that's had an investment tax credit available for a long period of time. So there's very clear rules and regulations around what is eligible for the investment tax credit. But with the Inflation Reduction Act, it boosted up the potential tax incentives that are available for geothermal systems. We're also seeing a lot of technological advancements in geothermal. Couple things we're seeing are inclined boreholes. Borehole drilling, where you're actually drilling to get to the earth, is very expensive, and you have to be able to punch a lot of different holes. The inclined boreholes, they kind of go in like a pyramid shape, and they get higher performance and higher output per borehole, which can help with the project financials. The other thing that we're really bullish on is ground source heat exchange, which is you're actually drilling deeper and you're getting into ground source water, and you're using that to be able to temper a closed loop. So less drilling that's required, and you're able to get high performance out of those systems. All right, want to hit on this case study, and then we'll go ahead and do a poll and round things out. So I have in parentheses there a reality-based case study, because a lot of times we go into this and we present a case study that's all rainbows and ponies and everything's great, and wow, Trane, you're the greatest thing since sliced bread. What we've done here is taken a very real scenario. This is a Fortune 500 company that has a commitment to net zero 2040. They are in the automotive sector, so they are tied to the supply chain opportunities and demands around decarbonizing. They're electrifying the vehicles that they manufacture. And they have a warehouse in Eastern Pennsylvania that's about 80,000 square feet, and it has a boiler that is at end of useful life. So they want to be able to replace that boiler, and they want to replace it with an electric source of heat to align to their net zero commitments. From a corporate level, they're all nodding their head and they're saying, yeah, absolutely, that makes a lot of sense. The local level is kind of playing nice with the corporate team, and they're saying, yeah, we understand, but we're in Eastern Pennsylvania. There's tons of natural gas available. It's cheap and abundant. I don't understand why we would do this. So let's get into some of the numbers of it. Or first, let's look at the solution. So you got to bring heat into this warehouse. The distribution system is one opportunity. But on the production side, we can either use natural gas for a heating source, we can use electric resistance, or in this case, we're looking at a heat pump that is air to refrigerant, the VRF systems that we talked about. Now, here's the financials that I promised. So we're using natural gas as our base case, and we talked about the efficiencies. Red here means low performance, yellow means moderate performance, and green means high performance. So efficiencies, the heat pump is going to be the highest. Annual energy consumption, heat pump is going to be the lowest. and the natural gas is going to be the highest. As we start to move to energy costs, this is where it gets interesting. You can see electric resistance is orders of magnitude higher than the natural gas alternative. But then the heat pump, which is still higher than the base alternative, is lower than the electric resistance. On the emission side, I mentioned to you that we'd see situations where the grid factor could result in higher emissions while electrifying. This is one of those cases. So if you go with electric resistance as your heating source, you're actually increasing the emissions at the facility. You are moving from scope 1 to scope 2, and there's value there. And this specific customer has a strong renewable energy purchasing team, so they know how to handle it. But you are on day one increasing your emissions. Now, in terms of first cost, the heat pump is going to be the highest system, and then incentives, you're going to see the highest for the heat pump as well. Now, I want to walk through these numbers. I know I'm starting to get to a little bit of an eye chart here, but this is where we get to the realities of heat pumps and electrification. So I think it's important for the audience that's here. The reality is, in Eastern Pennsylvania, relative to natural gas as an alternative, electric heat does not have a payback. There is not a solution where you are retrofitting a boiler and you are moving to an electric heat, just a one-to-one project, and you are getting to a payback. The cost of operating and the first cost of that system are going to be so low. Now, this customer, they said, we don't even want to look at natural gas as an alternative. So they basically took natural gas out of the decision matrix and they went to the below. So then it becomes, what's the cost of doing electric resistance heating? What's the cost of doing the heat pump system? And what are my payback periods? So in this case, you have a significantly higher first cost. It was $980,000 relative to $300,000. But with the incentives and the operating cost difference that came in, it was a 6.8-year simple payback on the heat pump. Again, I told you this wasn't a rosy, flowery case study. This is a very real business decision for the customer on how they're going to make this investment decision. So first thing they did was they down-clicked on the natural gas, said, we're not going to consider that. It's not aligned to our mission, our organization. So only bring us the other alternatives. Now, in this case, their decision was to go with the heat pump alternative. And the reason they were able to do that is because they're treating it as a pilot project and they have a plan to make it a case study within their organization. So even though 7 years was outside of their traditional payback windows, because they tied it to a story and a higher sustainability outcome and treated it as a pilot, they went the heat pump route. All right, Deborah, I want to do one more poll and then let's round this thing out.
Okay, and Trevor, great information. Thank you for everything you've done so far, but you're not done yet. So here's our next poll. In this scenario, which of these heating options do you think your organization would have gone with? Is it natural gas, electric resistance, or heat pump? Did Trevor make the case here?
Oh, I know the answer already. we deal with these organizations every day. The answer is natural gas. The money talks, but let's see how this breaks down. And maybe I'll be shocked. If I'm shocked, you'll see me hit the floor, and Deborah, you take the presentation from there, okay?
Well, I mean, you said it. The money argument is really hard. That's something that a lot of the buyers that we talk to, how do we make the business case? How do we explain?
If you look at the NYMEX natural gas market and you see wholesale natural gas at under $3, and you know your electricity rates are going up to 12 cents, 15 cents, or California 30 cents, it's a reality that we have.
Mm-hmm. Yeah. All right, we are going to give about, here's my 5-second warning, because we have a lot more to get to. So let's see what our audience is telling us. We're just about there. Okay, the big reveal. Well, natural gas, number one at just over 50%, but heat pumps at almost 41%, higher than you thought it would be?
Well, if those 41% of people, trevor.jolson@trane.com, shoot me an email. Let's do some heat pump projects together. I'd love to do that if that's what your organization is going to commit to. But no, it's great to see. And again, like the catalyst to this presentation is we're absolutely seeing the demand for heat pumps because of the recognition of the need and value it brings to corporate sustainability journeys. Now, for those that are dealing with the realities of dollars and cents of natural gas as an alternative, how we wanted to round this out was if your sustainability commitments aren't enough to change your to change your internal behaviors. So for our client there, it was. Their commitments to 2040 are absolute. They are all in from the sea level on down. So they told us don't look at natural gas, just look at the electric. But we know that's not the case for all others. So what are the other mechanisms that are going to support you as you start to look at heat pumps and electrifying your heat? The first is we are seeing increasing incentive for electrification across the country. I called out 3 of the more attractive programs here: state of Massachusetts, state of New York, and then Pacific Power, which is in Washington State. The Massachusetts program is for all air source heat pumps. The New York Clean Heat program is for avoided MMBTUs. So it's actually looking at how much natural gas you're displacing. $80 per MMBTU is a lot. $2,500 a ton is a lot to be able to support the project. And they're the type of support mechanisms that can change an investment decision for an organization. The third one I added, Pacific Power, I just really like. So electric resistance is one way to electrify your heat, but it's generally an inefficient way. And what we're seeing from Pacific Power here is they agree. What they're actually doing is paying you to go from electric resistance heating, which is somewhat the standard in Washington State, to heat pumps, because they're saying there's massive efficiencies of going from one electric technology to the other. So I thought that was a really unique incentive that was out there that we certainly wanted to call out. Now, the other side is the sticks. We're seeing increasing regulations tied to emissions, specifically as it relates to building performance standards. For those that fall under a building performance standard, such as local law 97 or what we're seeing in Energize Denver, those are the end use customers that have a supported business case for going with heat pumps and going all electric, because the fines that are associated with staying on fossil fuels in that market are so substantial. So as we start to see more building performance standards come through, natural gas bans are a thing that have been out there. They've kind of calmed down a little bit, but these building performance standards are where there's going to be an expectation to get off of fossil fuels, or there is going to be an expectation to reduce emissions or energy use, and heat pumps are absolutely a way to do that. All right, the last thing I want to hit on here is technology advancements. I would say that heat pumps are our #1 focus for R&D as a company right now, as a manufacturer of HVAC. There's a number of areas that we expect there to be advancements. These are some kind of cool phrases. I'll try to break them down for you. Vapor recompression is mostly tied to industrial heat pumps is what we're seeing. And what's happening is you're taking an existing, already compressed stream of either air or refrigerant, and you're boosting it up to a higher level. So if you need to get to high pressure steam, you can take low pressure steam, or you can take something that a traditional heat pump may be able to get to, and you can use a vapor recompression process to boost it up. So that's really going to help with the industrial side. We referenced the DOE earlier. They actually have something called DOE Earth Shots, and then they have something called the Heat Shot, which is focused on industrial heat pumps in particular, and recompression is going to be a big part of that. Vapor injection is another area that actually allows for performance in low ambient temperatures. So you're able to expand in the compression area the amount of pressure that that compressor can run under. So in those ultra low extremes, vapor injection is going to allow you to maintain high COPs and maintain performance. Last one I want to hit on is tailored refrigerants. So we referenced that refrigerants become a bigger part of your building when you move the heat pumps. We're seeing advancements in moving to low global warming potential refrigerants. We have a belief as it relates to heat pumps, especially here domestically, what we're going to start to see is a refrigerant that is more closely tied to the use case in the local market demographics. So something that's really interesting is we actually use propane as a refrigerant over in Europe. It's called R290, and we have a heat pump that runs off of propane. The reason we don't do that here in the United States is because we have different rules and regulations around flammability, so we can't use propane. So we have to use the refrigerants that meet the local market conditions, but we're going to continue to concoct and have our chemists work through refrigerants and partner with the refrigerant manufacturing companies to enable refrigerants that allow higher performance and also allow less sustainability or environmental impacts tied to that refrigerant. All right, so I'm going to hit on the closing statement here, and I'm not going to read these bullet by bullet. From a common mistake standpoint, when you're going through your electrification journey, I think the most important one is not tying your asset renewal strategy with your sustainability strategy. And that becomes both a common mistake and a best practice. The best time to address a electrification project is when you have a heating system that requires an upgrade because it's either failed or it's outlived its useful life. So when that happens, you have more of a support mechanism for doing an electrification or heat pump project than if you try to bring the asset out before it's fully gone through its life cycle. So best practice is look for where you have assets that need renewal. Another one, and this can be slightly more for the industrial environment, but it does apply to the commercial and institutional as well, is a lot of times we see customers running their end-use assets at a higher temperature than is actually required. So earlier we talked about 120 degrees, 140, and 180 degrees. The reality is we need to understand what are the actual temperatures that we require to run an asset. And we should evaluate those and audit those and see if we're potentially running at higher temps. Because if we can get to lower temps, we have more technologies and more efficiencies that are available. And if we can't get to higher temps, maybe we can decouple that one asset, have it run on its own, and then allow the rest of the loop to be able to run together. So my closing statement is the one that's highlighted here is, as it relates to heat pumps, they are having a moment. And if you are able to put your project in the spotlight, if you can highlight your story and really make it a success of your leadership as it relates to corporate or institutional sustainability, it's going to help you get the project across the finish line. I think we're still in the stages with heat pumps where it's a mature technology, but we need to find the right applications for that technology. And when we do, we should be shouting it from the mountaintops to bring the whole market together.
Okay, and I'm going to come back in for this last poll question. Where would you place your organization? We are not committed to net zero. We are committed to net zero, but it's too early to address electrification of heat. Or we are committed to net zero and we need to address electrification of heat now. So give us this last answer as we prepare for the Q&A. We will get as many questions answered. There are a ton coming in. That's the technical term. We'll get to as many as we can, and the Trane team will follow up with those that we don't get to live.
Yeah, we absolutely will. I was a little bit more lengthy in my comments than I anticipated, so we'll commit to following up with answers to the questions. I think probably be able to do 2 or 3 here live.
Great. Okay, and the audience appreciates that, as do I. And I'm just going to, not even a 3-second warning this time, and let's just jump and see what our listeners are telling us. Interesting. We are committed to net zero and need to address electrification of heat now, 41%. Close behind, we're committed, but it's too early to address electrification, 39%, and about 20% who are not committed to net zero.
I think what's super interesting is if I remember the last poll, those that thought that they would go with heat pumps was 41.1%. So there's probably a massive overlap between those that look at the heat pump technology and those that recognize that they need to address electrification heat now. Almost the exact same percentage of the audience.
Could be. Interesting thought. All right, Trevor, we're not even going to give you a moment to catch your breath. I'm going to jump right into these questions so that we can get a few in the last few minutes that we have. The first one, how effective are heat pumps in climate zones that are usually humid? And no surprise, this comes from somebody in Texas.
Heat pumps in, well, I am based in Texas, so I deal with a heat pump in a humid environment. I am actually going to pass on that question, if that's all right, from a technical perspective, because I am not a dehumidification expert and I feel like I won't give a good answer. So I'd rather follow up with my colleague and give that individual a response.
That is fair. I appreciate that. All right.
Yep.
As I jump to the next question, you'll see there's a list of sources here that Trane has provided, a lot of links. If you've downloaded the PDF of the slides, you'll have all those available there as well. Next one, more confirmation than a question. So heat pumps can be through gas heat too?
Yeah, actually, I'm really glad they asked that because there's a comment that I meant to make. There is a bridge technology. We do dual fuel heat pumps. And what that actually allows for is you run as a heat pump until you reach the extremes where either the efficiency levels aren't there or it can no longer perform. So it allows you to use natural gas as the backup fuel source rather than use electric resistance as the backup fuel source. So if you're running into a situation where you have electrical constraints, or if you just have apprehension of going with an all-electric system, heat pumps that use natural gas as a backup fuel source are a great alternative to look into.
Okay, and the next one, we're going back to the money. It all comes down to the money. It's hard to secure. It's hard to secure funds for sustainability initiatives. Any advice on convincing the higher ups to invest in heat pumps? What's your most compelling argument here?
Yeah, my most compelling argument for investing in heat pumps is tied to all of the regulations that we're seeing out there. And assuming that this is a question coming from someone that's here in the United States, if you look at the heat pump penetration in Europe, which is a marketplace that is more advanced in terms of its renewable energy adoption and its move away from fossil fuels and sustainability, much more significant over there. So as we start to move into more of a renewable energy based environment and a clean energy environment and see more regulations around it, heat pumps are going to have the support mechanisms and are going to have the incentives. So the best way to be able to go to your boss or your main stakeholders is show them the incentives that are available for heat pumps and show them that people are giving money to support these projects that can be leveraged by your organization.
Okay, and next question. Again, a money question. Do you see heat pumps becoming a cheaper option to install than other modes of heating and cooling?
The answer is the worst answer, which is it depends, but I'll explain why it depends. So if you are addressing your heating and your cooling with a heat pump, and you need to replace both your HVAC system that does cooling and your heating system, what a heat pump allows you to do is replace that with a single asset. So all of a sudden you're in a situation where it's cheaper, you don't have to maintain both of those assets, and it can work for you. But very rarely do we actually replace two assets at the same time. And sometimes we see that we're on a roof there and we're in a basement there, and it can be tough to tie those systems together. So when you have the scenario that allows you to replace two assets with a single asset, the answer is yes. If you need to use a heat pump simply to replace a boiler standalone, I think there's a long journey to go before there's price parity there.
Okay, we're almost out of time. I'm going to sneak one more in here. I have several buildings to manage. Any best practices you can offer to determine which to electrify first?
Yeah, I'm going to go back to those three circles that had the emissions factors, the spark spread, and the electrical infrastructure. And the best practices from a portfolio view is making sure you evaluate your cost of natural gas, your cost of electricity, the incentives that are available, and the emissions factors of your grid. So if you can get a portfolio level view of that, very quickly you're getting to a priority of, this is the market where a heat pump project can be successful, and I can demonstrate the capabilities within our organization and really have this shine. So if you're looking at those variables, if you're charting those variables, and that's something we do with our clients, you're finding the overused phrase of the low-hanging fruit, but you go through some calculus to get there, so it makes the fruit even sweeter.
Okay, and that's the note we're going to end on. Trevor, thank you so much for sharing your expertise. It's always a pleasure. And thanks to the team at Trane for making this all possible. And finally, thanks to all our attendees, a very engaged bunch I can see from all the questions. And again, Trane will get back to you on those. So thanks for your participation, and we hope to see you back in our next webinar, and enjoy the rest of your day.
Take care all, thank you.